Okay. Uh, Good morning, all. In last class, we just started with the introduction of first module, right? Where we covered the terminologies like cryptology, cryptography, cryptanalysis, and what is crypto system, isn't it? The term used throughout in this chapter, we have discussed in the first class, okay? So the next thing is we also checked other terminologies used like plain text, ciphertext, decryption, encryption, and also symmetric key and the public key, isn't it? And then we moved on to the Kirchhoff's law, where he states that even though crypto algorithms is known to the attacker, but the key should be kept as secret, right? So that is what we study under Kirchhoff principle, and also how this using symmetric key encryption and decryption is done. That is also we checked, and we just started with the first simple substitution cipher, isn't it? The four classic ciphers are simple, double, codebook cipher, and the last one is one time pad. Okay. So please listen. If I'm not audible, please unmute your mic and tell me. Fine. Okay. Next, the first thing is simple substitution. As we discussed, the plain text will be given and the key will be given, and based on the key, we will generate the ciphertext. Okay. Using the same key, moving backward will get the ciphertext, right? So if the key used for the simple substitution is 3, then that method we call it as a Caesar's cipher, right? Till here we started in last class. So, and also we saw the pic representation where the simple substitution cipher is followed, right? So the next part, here, this is the slide where we stopped in the last class, isn't it? So let's see what is Caesar cipher like. Considering an example here, you can see here Caesar cipher. If I say Caesar cipher is used for the encryption and decryption, then that says that the key value is 3, isn't it? So using key as 3 for the plain text, a ciphertext is generated here. Let's start with this. See, consider if the ciphertext is given. See, please look into this. Here, the ciphertext is given, not the plain text. You have been asked to find out what is the plain text for this ciphertext if the Caesar cipher is used. I'll repeat. If this is the ciphertext is given to you, okay, then if I say the Caesar cipher is used for the encryption or decryption, then find out what will be the plain text. So, what should be the key used for this? Yes? Anyone? What is the key used for Caesar cipher? Anyone? See, in the previous slide, I said yes. See here, the shift by is 3, then it is a Caesar cipher. That means what? Here the key is 3. Okay. So for this, you have to move backward when you are generating plain text from the ciphertext. Okay. I hope this is clear, right? I've just calculated and written the plain text here. For this ciphertext, when we apply key as 3, you will get the plain text as this one. Okay, SpongeBob SquarePants. Fine. So you can analyze this since you have studied this part in the cryptography. I'm not stressing much upon this. Okay. So and first module is very easy. Okay. So when we apply key is equal to 3 and move backward, then you will get this as a plain text for this ciphertext. Okay. Next, we'll move on to the next part. That is, see, if let me consider an example as this example only. Okay. If I say this is the ciphertext given, okay, then the attacker, or if the students, I mean those who are solving the problem, what they'll apply what will be the n value here to find out this plain text for the ciphertext. or if a plain text is given or you are asked to find out ciphertext, then obviously you will try the value of n from 0 to 25, or you can say, as I said, this cipher is used on the English alphabets, right? English letters, isn't it? So since it is applied on the English letters, so n can take the value from 0 to 25. Why it is 0 to 25? As you know, English alphabets, the count is 26, isn't it? So n can take the value from 0 to 25. So you will apply n value as 0, and you may try out by substituting n value as from 0 to 25. Then you may, at some point of time, for some value for n, you may find out what the required answer for your question. Either it may be from converting plain text to ciphertext or ciphertext to plain text. Okay, so here it's given an example is considered here where key value n is equal to 7. If n is equal to 7, for this plain text you will obtain this ciphertext. Okay, so let me consider an example where attacker will suspect that the received text. So consider whatever the message received by an attacker is encrypted with the simple substitution method. I'll repeat the example. Consider like an attacker, he will receive a message and he'll suspect that it is encrypted using with a simple substitution cipher, like using shift of n, right? N can take the value from 0 to 25. Okay. Then what he'll do, as I said, he will try out all possibilities. That is, he will try each of the 26 possible keys, right? And then he'll decrypt the message, and at the end of it, he will be succeeded with his task, right? So this trying out all the possibilities, that is trying out all 26 possible key, this approach is called as exhaustive key search. Okay, so here it's given. You can see here a simple substitute. As I said, if attacker made a guess that is encrypted message is done using the simple substitution, then consider this is the ciphertext used here. Then he'll try out all 26 possible keys, right? At some point, he may find out what is actually the plain text is. Right? How will he find out the plain text for the given ciphertext? Obviously, if he gets a statement, if it is in a readable form, obviously he'll come to know that it is a plain text, right? So trying out all 26 possible keys, this approach is called as exhaustive key search. So this is very important question under this module, where they'll ask you to explain exhaustive key search, or what is exhaustive key search, explain with an example. So that is one important question here, where you have to take one example like this, okay, and try out n values from 0 to so and so, and get the answer as a proper readable form statement. Then you can see by following this method, we'll get the required plain text, and this approach is called as exhaustive key search. Okay, I hope this part is clear now. Fine. So we'll move to the next part. The next thing is what should be the key size that is used for the encryption and decryption. So it plays a very important role. Okay, so what should be the key size that should be used for the simple substitution? That is very important here. Let me consider this example, okay, where you can see here plain text is given, where alphabets are considered from A to Z, okay, and the ciphertext is given. For A it is J, for B it is I, for C it is again ciphertext as C, right? So if this is the case, what happens? Is it possible for the attacker or anyone to try all possible keys in a reasonable amount of time? No, right? See, if I give you key value as 4, then A should take D, right? A, B, C, D, E, right? So, but here it is given as J. For B, it is given as I. I comes before the J, right? In the proper order of alphabets, I comes before the J. But for B, here it is ciphertext obtained as I, right? See, in this case, it is not possible to try out all 26 letters for the value of n, right? So what happens in such case, following this 26 factorial ways, where you can say it is 2 power of 88 possible keys. So at a reasonable amount of time, it's not possible to use or try out all the possible 26 ways. Okay, so you can see that with this, the key size or the number of possible keys used for the encryption and decryption under simple substitution should be large enough, so that attacker should not be able to try out the possible keys within a reasonable amount of time. I hope this part is clear to you. Yes? Uh,
Ma'am, could you repeat again?
yes, okay. See, let me consider this. See, if attacker, consider that he received a ciphertext and he believes that it is encrypted using simple substitution. He'll assume that this ciphertext is encrypted using simple substitution. But the thing is, he has to find out the key. What is the key used for this ciphertext, isn't it? So what is the left out option for him? It is that, as I said, simple substitution is applied on the English alphabets. He can try out 26 possible keys. Either n can take n can take the value 1, or n can take the value 2, or it can take 25, or it can take 26, isn't it? So that is the only possible way using which he can find out the plain text, isn't it? So he will stop checking the value of n at some point of time where he gets a readable form statement, right? Wherever he gets the readable form statement, he'll stop trying the value of n. Okay, say he may get a proper readable statement when n is equal to 5. Then he'll stop his search or trying out the possible keys. Okay, so this is one way to find out the plain text or the value of key. This method is called as exhaustive key search. But whereas here, consider this example where looking at this, it's very difficult to find out by trying this possible keys. That means factorial of 26. Trying out this ways for this example is very difficult. Uh, are you able to follow now? Yes?
Yes.
Yes, see here, for A, the ciphertext generated is what? J, right? For B, the ciphertext generated is I. But in the regular, whenever you write from A to Z, in this format, I comes, see here, I comes before the J, right? So if I'm using any shift here, for B, it should be after J, right? Either it should be K or O, something like that, right? But not I, isn't it? So in this case, it is difficult to follow this method. Hope you are getting my point now. Yes? Yeah, if this is the case, then this exhaustive key search will not work out. Okay, so this is one where you have to be very careful while choosing the keys. So key should be very large enough to find out for an attacker in a reasonable amount of time. So this becomes a drawback for this method, isn't it? Yes or no? So then what he'll do, randomly he can't check each and every value of n. So what he'll do, he will use a fast computer. So consider attacker uses a fast computer and he'll be able to test around 2 power of 40 keys each second. I'll repeat. He'll consider a fast computer where in each second he will be able to test 2 power of 40 keys. Okay. Now, if I choose the key space or the size of the key is 2 power of 56, I mean some value I'm taking 2 power of 56, which can be exhausted in 2 power of 16 seconds. That means in 18 hours. The attacker can find out if I'm using a key size of 2 power of 56, then he'll be able to find it out within 18 hours. If my system, the fast computer tests 2 power of 40 keys per second. Okay, so why I'm saying this, see, whenever we choose a key for encryption, then it should be large enough so that the attacker should not be in a position to crack it down. Okay, that's why I have considered this example. But according to this, as I said, this becomes what problem for him. He may not able to find out by following the exhaustive key search, right? So what have so let me come to this examples later. Okay, now you can consider this. Okay, so whatever example I considered in the previous slide, for that I've taken, I mean, to solve such problem, I've considered one more problem here. Okay, so consider this is the ciphertext that is given for you, and you will be asked to find the key, right? See, if this is the ciphertext, it is difficult to follow, as I said, the 26 factorial possible keys, right? So in such cases, or in this kind of problem, what the attacker will do. So one second. Okay. So what attacker will do? As I said, he can't try out all 2 power of 88 simple substitution keys, right? So he has to use the other technique other than the exhaustive key search. So what he will do, he will take the, what do you say, frequency count, English letter frequency count. That means you whenever see an English word, say simple, here the word simple is used, where we know that the letter E and A will be used more in English words, isn't it? Do you agree with me that? Letter A, letter E, letter T, or letter S. So these are the letters most frequently used in English words. Whenever you make a statement, these are the most frequently used letters in each and every word in a statement. Okay. So based on that, he'll consider the frequency count of each and every letter. If you look, say it's a general representation considered. Okay. You can see on an average, A is used around 0.08 thing. That means compared to all other letters, you can see E is used at a E is used very frequently in making a word, right? In forming a sentence or making a word, E is used very frequently. After that, A is used, and also R, S, and T. Okay, so this is the general English frequently used letters are considered and graph is obtained. Looking at this diagram, you will come to know which are the letters which are most frequently used. Okay, now we'll understand why I have considered this graph. Let's move to the next slide here. This is the problem which I've considered in this problem. Okay. So consider this is the problem where he can't try 26 factorial possible ways. Okay. So what the attacker will do, he will find the statistics. Okay. So he will make a count of each and every letter that is present in the English alphabets. Like A, how many it has occurred in this ciphertext? It has occurred 21 times. The letter B, it has occurred 26 times. You can count it in this. Okay. So counted here, or each and every letter, and written the statistics here. A 21 times, B 26 times, okay. With respect to this cipher text, this count is written, okay. Now the thing is, what attacker will do, he'll compare the English letter frequency count with the cipher English letter frequency count. That is whatever we considered or drawn from this cipher text. So he prepared a graph like this for the English letter frequency as well as cipher text English letter frequency counts. So looking at this, do you remember this graph is generated for this cipher text, okay? Whereas this graph is generated with respect to the English word that we form in our statements whenever we talk or whenever we write, okay? Based on that, this is generated. Now you can see here, looking at F, okay? It is used more frequently in the cipher text, and then A, and then B, right? And then P and Q, isn't it? So when you look at this graph, you can make out that F is the most common letter in the encrypted message, isn't it? F is the most commonly used letter in the encrypted message, right? But if you consider this figure, E is most commonly used letter in the English language, right? So considering this, what attacker will conclude? What he will conclude? The letter F has been substituted with the letter E. So if he decrypt the cipher text, what he will assume, the letter F is most frequently used in the cipher text. When he looks into this graph, he'll conclude that E is the most frequently used letter in the English. So he will substitute F with E. Okay. Continuing in this manner, what attacker will do? Attacker will try likely substitution until he recognizes the words. Like it's a trial and error kind of thing, but he will do the trial and error based on this graph, okay. So he will recognize the words. At some point of time, he will confidently says he'll form a proper statement which will be in a readable form, okay. At that point, he concludes that, or he will decipher the cipher text and he'll be with the plain text. So he will succeed in his task, okay. So whenever the exhaustive key search fails, then there will be another option where the attacker will follow this method. The letter frequency count he'll consider, and he will guess the letters, okay, based on this, considering these two graphs. At some point of time, he'll end up with a readable statement. Then he will conclude what is the plain text for the given cipher text. Okay, I hope this part is clear now. Yes? Someone answer me.
Yes, ma'am.
Okay, fine. So next, you can see the crypto system is secure if best known attack is to try all keys, right? So that is what we started in the first method, right? And the next one is crypto system is insecure if any shortcut attack is known, right? And then insecure cipher must be harder to break than a secure cipher. This is a what saying that is there with respect to the crypto system, right? So now, since we solved the problem under simple substitution, let me give you problem here. I want you to try. So if you have pen and paper, please try out this. So this is the plain text given, okay, and key given as 4. Apply simple substitution and then find out what is the cipher text for this plain text. So I have given the table as well here. So when you make a shift of 4, A will take the place as E, okay. So I want you to try out this. I'll give you 2 minutes time. Please hurry up. So since I've provided you this table, I hope this is easy to solve the problem. Yes? Anyone?
Yes, ma'am.
Yeah, please try it out. Try it out and tell me the answer. See, I hope I'm clear to everyone. Are you able to follow whatever I'm explaining in this class? Yes? Yes or no? Hello, are you all there? Are you all there in the class? Huh. Answer me. Are you all followed whatever I explained in this class?
Yes, ma'am. Yes, ma'am.
Solve this. Yeah, solve this problem and tell me what is the answer for this. I'm studying data encryption. Key size is 4. I've given the ciphertext for each and every letter in the English language. Done? Yes. What is the answer? Yes, what is the answer? So it's not difficult problem. It's a very easy, right? Okay, MEQ who has answered. Okay, Bhavna and Cypria. Okay, let's cross check it. MEQ W X Y H S X Y H C M R K. Cypria, you must see there, right? Okay, then H E X E I R G V C T X M S R. Okay, correct. Cypria, you correct it. Okay. Huh. Yeah, good. So what about others? You all there in the class, right? Huh? Yes? Then okay, let's consider the next example. Okay, find the plain text and the key from the cipher text CSYEVIXIVQMREXIH. So for this cipher text, I want you to find the plain text as well as the key. Okay, and consider this is example for simple substitution. This ciphertext is generated using simple substitution. So I want you to find out what is the key value and what is the plain text for this. Will you do it? Yes? See, you have to answer me. If you are not able to do it, then let me do it. I want the answer. At least say yes or no. Hmm. Huh. I can give you the hint. See, n can take the value from 1 or 2 or 3 or 4 or 5. See, you have, so this is the table. If you apply key is equal to 4, okay? And one more thing, this is the table, you will get it when you apply k is equal to 3, okay? So what is the first letter? What is the first letter in the question? It
C.
is C, right? Yeah. So just check in the previous this thing. Wait, or I can drop this. To paste. I can't paste it here. Yes, answer is 3. No, it's not. Anyone else? Is anyone trying? Yes or no? CSWEVIXIVQMREXIH. What is the plain text for this? The solution is you have to try out. Yes, how to find. See, you have to find the key here by trying different values for n. And I'll tell you, n can take the value from 1 to 26. Why it is 1 to 26? Because we are applying simple substitution on English alphabets, right? How many alphabets are there? 26 alphabets are there, right? So obviously, n can take the value from 1 to 26. So you have 26 factorial different possible ways to find out the key. Annapurna, key is 4. Okay, then what is the plain text for this? If key is 4, what is the plain text? Very good. It is, so since it is ciphertext, you are asked to find out plain text, you have to shift backward, right? So here 1 to 4 I have tried. For 1, when n is equal to 1, I mean when you make one shift backward, then this is the plain text that you get. But this is not in the readable form, isn't it? So when you try n is equal to 2, this is the plain text that I got, but it is not in the readable form. N is equal to 3, this is the statement that I get. So it is not in readable form. So when I try n is equal to 4, I got a statement saying you are terminated. Now obviously it is in readable form. The attacker will conclude that this is the plain text and n is equal to 4 is the required key. Okay, I hope this is clear. Yes? Okay. Then we'll move to the next topic. Okay. So the first classical crypto is simple substitution. Next one is double transposition. Since in simple substitution, as I said, we have to use larger key space for the encryption and decryption, isn't it? But it is failed when we studied cryptanalysis second one, where the English frequency count, letter count is considered, isn't it? So even though that method is followed, considering exhaustive key search and also English keys, English alphabet letters frequency count, the attacker may able to find out what is the key or what is the plain text for the ciphertext, isn't it? So to overcome such problem, another method is used, that is double transposition. Actually, there are many wherein under transposition technique, you are supposed to write, study in your syllabus double transposition. Fine. So what is double transposition? Let's consider. First, let me tell you how it works. First, the plain text will be given and it will be written in a array form. Okay, the size will be mentioned and you are supposed to write it in that way. Okay, and then you have to permute the rows and columns according to the specified permutations. So what is the first thing? Whenever the plain text is given, we should write it in an array form of a given size. Okay, and then permute the rows and columns according to the specified permutation. Well, first we'll consider an example. Let me consider this is the plain text, attack at dawn. Okay, so if this is the plain text, then the size is also given. It should be written in the matrix form 3 cross 4. What does it mean? The array has to take the size 3 cross 4. So the plain text will be written in the matrix form where the number of rows should be 3 and number of columns should be 4. So how many rows are there? 1, 2, 3. Okay. How many columns are there? 1, 2, 3, 4. Okay. This is the first step. Next step is what? We have to permute to rows, right? So according to the specified permutation, right? Here, transpose, or you can say permute the rows according to the specified permute. See here it's given, you have to transpose it so that if the ciphertext fell in the hand of attacker, whatever ways he tries to crack it, he should not be in a position to get the proper plain text. That's why we are following the rows transposition and column transposition here. So this solves the problem that we started in the previous method. Okay, what is the row transposition followed here? Whatever written in the first row, second row, third row should be transposed to third row, second row, and the first row. They should be transposed to the given specified permutation. After transposing, let's see how the matrix will be written. So this is the next thing. So whatever for the plain text, the matrix I have written, I have considered that here. When you applied this transposition, let's see what is the matrix that you get here. So 3, third row is this one. So sorry, here the first 2, 3, right? They should be written in the form of this 3. So 3 should come in the place, in the first row. So that's why this dawn is written in the first row. Okay, next 2. So this row, second row is written as it is, and then comes the first row, that is ATTA, that is written here. Okay, so this complete plain text is converted into matrix form, and then we applied row transposition according to the given permutation or the specified permutation. Okay, once we're done with the rows transposition, what is the next step? As I said, next is the column transposition. So how many columns are there? 4 columns are there, right? So this should be transposed according to the specified permutation. What is the specified permutation for this problem given in this explanation? It is 4, 2, 1, 3. Okay. Let's see after transposing this. See, this should be applied on this resulted matrix. Okay, not on this. Fine. So after applying this column transposition, first which column we are supposed to write? First we have to write the 4th column, right? The 4th column. That's according to this, which is the 4th column, NTA, right? So I'll write that in the first place, that is NTA. Next is 2, right? Which is second column here, AKT. So AKT is written, right? Next one, what is there in first column? DCA. So that is DCA written here. The last one is third column. You are supposed to write it at the end. So that is WAT. Okay. When you apply the column transposition, after applying rows transposition, on that you have to you are supposed to apply column transposition. Okay. Once you applied it, you will get this matrix. Okay. Now this will be the ciphertext. Okay, the ciphertext is then can be written as, say it is in the matrix form, right? So now we are writing it in a readable form. I mean the like this. Say like this, we are going to write it here. So how it is written? N A D W T K C A T A T. Okay, so this is the ciphertext generated for this plain text. I hope this is clear, like how to apply the rows transposition and the column transposition, right? Now, uh, in the previous slide, I mean, in this slide, we saw how it is, ciphertext is generated. Now we'll see how ciphertext is decrypted, right? Do it in vice versa, like the decrypt ciphertext, first again put it in the same array, that is 3 cross 4, okay? This one. See, this matrix is same as the one which I considered here, right? So I've written as it is, okay? On this first, we have to apply, apply the column transposition, okay? On the same, on the resultant matrix, you are supposed to apply the row transposition, okay? Once you apply it, you will get the plain text. Since it is in matrix form, if you write it as a statement, you can read it as attack, ATTACK, attack at AT dawn, DAWN. Okay, I hope this is clear. First apply, while decrypting, what you have to do, first apply the column transposition, and the resultant matrix apply the row transposition. Okay, so after applying row transposition, whatever matrix that you get, that will be uh, this thing, okay, final plain text. Now what will happen if more than 3 cross 4? See, that can be considered. See, I'll give you problems other than what is there in the text, in the explanation. I'll give you some other problems at the end of the module 1. Okay. See, what happens if more than 3 cross 4? Then for such message also, you have the what specified permutation will be given. So based on the specified permutation, you have to find out the ciphertext or the plain text. Okay. So I'll repeat. For see, whatever here, the transposition that I considered here, row transposition and column transposition, this is I have considered to solve this problem. It can be different. It doesn't remain same for all the problems. Okay. The row transposition and the column transposition, it depends on the problem. I mean, I can give you the different values for the different problem. It doesn't remain same for all the problems that we're going to solve under double transposition. Okay. I hope I'm clear. Huh? Okay. Now you have next class, right? Okay. Yeah, that's all for today. Okay. I hope whatever I explained and this class is clear to everyone. Yes? Yeah, I don't get any answer. Why is that so? Huh? Why is that so?